Hello everyone, welcome to my Matlab tutorial. So this is the Matlab that you can open your Matlab and you can run in your command window, but all operations I will show using the Jupyter notebook. In this tutorial I will show vector and matrix. So this is x equals to 1 and 2, so this is like a row vector. I can write say 1 2 3. Okay, so yeah, so this is a vector, so you, in this way you can also for say 5 6, right, you can increase the size of this vector, and also you can write using the comma separation. So this will be the row vector, and this vector you can write inside this bracket. Okay, so for column vector you need to use the semicolon, like for 3 semicolon 4 is this vector, this is a column vector, so you can write more semicolon 5. Yeah, so this is the vector, and you can also find the transpose of a vector, say y, the transpose of a vector, that is y is now a column vector, so if you find the transpose of y, it will be a row vector. Okay, so this is the way you can define a vector. Okay, now it's a matrix. So this is the matrix A. For example, this is a 2 by 2 matrix A. So this 1 and 2 and then semicolon, so that will be first 1 and 2, it goes up to the row wise, and then semicolon it will write another row 3 and 4. Okay, so the same way you can define also another vector B equals to this 5 6 7 8. Now we can do some operation. So this is A vector and this is B vector, sorry, this is A matrix and this is B matrix. So you can do some operation in this 2 matrix, like A plus B or A minus B. So you can do this operations like A into B. Okay, so now you know how to define a vector and how to define a matrix. Okay, so another thing for this is like you can find the size of a matrix. Say this is A, this is 2 by 2 matrix, right? Okay, so if you use A star A, that is the A multiplied with A, and A square, like this is the square of A, that is the same thing, but if you write A dot cap sign then 2, this is like the different thing. So this is actually the pointwise square of all element of A. So now I will show you. So this is the A matrix, right, that I have written. So this is like a 2 by 2 matrix. For example, this is a say you can also extend it like, okay, yeah, so now this is a 3 by 3 matrix. You can make it a more larger size of a matrix, right? Then yeah, this is like a 4 by 4 matrix, or even may not be necessary to be square, maybe for this different size, right? Yeah. Okay, so now for example, so in here, say A is just a simple 1 2 colon 3 4. So this is a matrix, 2 by 2 matrix. Now we will find A star A, that is a square, and A cap 2, this is also a square, but A dot square, this is the different thing. See, so in here A and A, so this is A square, so this is A, and this is the A square matrix, and this is also A square, but this is the pointwise square. So for example, 1 square is 1. Say okay, I am writing here the semicolon, so it will show only this A and A dot square. So that means 1 square 2 square is 4, 3 square is 9, and 4 square is 16. So this means like this. It's not just the square, but A star A is like the A square. So both are different operations. So yeah, this is really a powerful operation, but when you use these things, you need to carefully use this. Okay, that is the element wise operation, like star, point, star, or point slash, point cap. So these are the element wise operations. Okay, for example, p and q two vectors, like 2 and 4 is p and q is 3 and 2, right? So we can do this point wise operation, say p dot star, right? That means p and q, the product of p and q element wise, that is 3 into 2 is 6 and 4 into 2 is 8, right? Or p dot slash q, that is the division, point wise division, that is 2 by 3 is this, or 4 by 2 is 2, or point wise p dot cap q, that is the all are the point wise square, that is 2 cube 4 square, like 2 cube is 8, 4 square is 16. Yeah, so this is the way we can do the point wise operation, or we can do the point wise for two matrix. Yeah, so that is I already have shown in here the point wise multiplication. So you can also use this matrix, like, okay, so for example, so okay, this is now a matrix, right? So then you can do these things for this matrix point wise. Right, so yeah, then this calculation you can do this point wise operation. So now p star q, that is the multiplication of p with q is a point wise multiplication, element wise multiplication, like 2 into 3 is 6 and 4 into 2 is 8. This is the way. Okay, so yeah, this is a B matrix, so we can find the inverse. You can write this like B cap minus 1, this is the inverse, and we can also write I and B, so we can find the inverse of B matrix, right? So the interesting thing is this B, say for example C is another 1, I can write B dot square minus 1, so it will be the element wise inverse. See in here, this is the C1 is the element wise inverse, is like 1 over 1 is 1, and 1 over 2 is 0.5, and 1 over 3 is 0.33, and 1 over 4 is 0.25. Okay, you can also find the determinant. For example, this is a B matrix, so the determinant of B is minus 2, that is 4 into 1 is 4, then minus 3 into 2 is 6, so 4 minus 6 is minus 2. So yeah, this is a matrix structure, like, okay, so this A is a matrix, A is a 3 by 3 matrix. So then you can find so you can find so this like 1 column 3 comma 3, that means the column 3, third column, right? 1 6 and 98, this means this 3 means like the column, and 1 column 3 is like the row wise. So row wise is like 1 column 3, all row, or all row, right? So if I write here 1, so this is like the first column. If I write 2, so this is the second column. This is interesting. And if I write, okay, say 2 and say 1 colon 2, so this means like the row will be from 1 to 2, so the row is 1 to 2, and column is 1 to 2, so column is 1 to 2, so this segment. Okay, so if we write say 1 1, that is just the first element. So this is the way we can this is this 1 1, these are the index, right? So in a Matlab, all matrix index actually started from 1, not 0. If I write here 0, in another programming language the index is started from 0, it will be wrong. Okay, so the minimum will be 1 1. Okay, yeah, so we can also find the size of this matrix, right? In here this matrix size is 3 by 3, because the number of row is 3 and the number of column is 3. Yeah. Okay, all right. You can also use the help, that is, say for example EIG, that is the eigenvalue. So we can use help, and then it will show the about the eigenvalue. There is a long description, so I just use now semicolon, so it will not show this. Oh, okay, it's showing now this. Yeah, so then you can also use these things, and you can use the eigenvalue and eigenvector. So for example, the matrix A that we defined in previous, it was A, so you can find the eigenvalue and eigenvector of this matrix. So these are the eigenvalue, eigenvector, and these are the eigenvalue of this matrix A. Okay, we can also define different types of matrix, like A matrix is 0, 3, so that is a 3 by 3 matrix with all elements are 0. We can define I matrix, that is an identity matrix. All elements will be, all diagonal element will be 1 and other elements are 0. So this 4 means like the 4 by 4 identity matrix. If I write 3, 3 by 3 identity matrix. We can define a random matrix like 4, so 4 means 4 by 4 random matrix, right? If I write 3, so it will be 3 by 3 random matrix. And for this matrix we can also solve a system of linear equations, right? So if a system of linear equations like Ax equals to b, there are here 3 equations, so we can write this set of equation in this matrix form. Here we can define A matrix, and we can define x variable, and we can define b, and we can also test this system whether it is you can find a unique solution or not. So then you can find the determinant, and if you know, then if determinant is non-zero, then you can get a unique solution from this system. So this is the A matrix. So this is the determinant. Okay, so for this matrix determinant is non-zero, that is you will get a unique solution. And this is the B matrix, so you can find the solution A slash B. So this is the solution for this, for the previous system. Okay, so in this system we can write this this system as a matrix form, right? So then we can find I think if I remove this semicolon, you can see this the matrix A, right? So then I tested the determinant, right? And then this is the B matrix, that is the right side of this system. So then this is the solution of this system of equations. That's very easy to find the system of find the solution of the linear system of equations. Okay, so more vectors, like if I write A colon 5, that is a vector from 1 to 5, and the increment is 1. So if I write okay from 1 to 5 and 0.5 in between 2 colon, that is the increment is 0.5. So you can see this, right? I can also find the length of this x. So here x, the length is 9, so that is 9 value you can see in this vector, right? And also you can see, okay, say x, so 1, that is this is the first element is 1, and say x2, this is the second element, right? And if you write okay, say 1 colon 5, so it will be the elements from 1 to 5, that is the index from 1 to 5, and here always index is started from 1 in Matlab. All vectors and matrix, the index is started from 1. Okay, so this is the line space that is in this function. This is a built-in function in Matlab. So in this function you can also define a vector. So for example, you can define it from 0 to 15, and we can find say 11 points, right? So yeah, so this is the 11 points from 0 to 5, and yeah, so if I say okay, say 6 point, so it's like 0 1 2 3 4 5, right? 6 values. Yeah, same way you can write it like for more, say 21. Yeah, okay. And another interesting thing is we can find the index, like we can use the find, and we can say okay, find out which x values is greater than 2. So these are the index number of this matrix. So this is, sorry, x vector. So this is the x vector. So and this is the index number for this x vector, and in this index number the value of x, the values in this x vector are greater than 2, and if you use this index again inside this x, then you can see those values which are actually greater than 2. Okay, yeah. So in here this is large, so I think I can semicolon this. Yeah, so then you can see this, right? So these values 2.25, and from this value to 5, all are greater than 2. Okay, next one thing, that is a MATLAB script file. So for example, if we want to plot a function like say x equals to this, so now we know this x is a vector, right? So we are defining x from 0 to 10 with a 0.1 increment, and we can define y as a sin x, right? Y equals to sin x. So we can, that is x and sin x, and we can plot this. Okay, so plot x comma y. So we can find this plot for this. Okay. Another thing is yeah, so this is the plot. So so this plot I can show. Okay, so you can see this plot. Okay, so another thing is the script file, that is, okay, another thing is about the script file. That is, in MATLAB you may have a script file, for example. Okay, so open plot test.m, you can so you may have the script file like this, right? So in the sin x and y, and the plot sin x comma y. So this is the script file in MATLAB. So we can run this script file, right? If we write simply just plot test, the file name, so then you can see this plot for this sin x. Okay, thank you for watching.